Alright class, so I just wanted to make a video on distance formula, and this image I thought was really cool is from onlinemathlearning.com, so I just want to make sure I give credit where credit is due. The reason I like it is because it draws the connection between the distance formula, which is here, and the Pythagorean theorem. So the distance formula is really just a version of the Pythagorean theorem on the coordinate plane. So if we wanted to find the distance between, say, these 2 points A and B, with these coordinates x1, y1 and x2, y2, we would just need to figure out the change in y and the change in x. So really what it is here is it's the change in x squared plus the change in y squared, and you take the square root of that whole thing. Because that's really the same thing as the Pythagorean theorem, right? The Pythagorean theorem is a squared plus b squared equals c squared. So if you take the square root of both sides, it's just the square root of a squared plus b squared equals c. So these are really just the same formula, and we can use this to solve some of these problems. Now, I wouldn't even memorize the distance formula. I would just use the Pythagorean theorem every time, because we all know that one. So here we go. Oh, everybody wanted to see my dog again. So there's my dog. Oko. So let's look at example 3. Parallelogram JECE has vertices of 1, 1, 4, 5, 7, 1, 4, negative 3. So is this parallelogram a rhombus? So that's something we just need to figure out. So let's go ahead and plot this. Here's our x and y axis. We'll plot the points JECE. And what we need to do is we need to look at our quadrilateral family tree again. And so if we need to prove a parallelogram is a rhombus, you need to prove one of these two things. So since we're studying distance formula, I'm going to use this one here, and it's a parallelogram with all 4 sides are congruent. Now, you don't need to actually prove all 4 sides of the same length. If we can just prove 2 connected sides or 2 adjacent sides are congruent, then we know all of them are congruent. Why? Because a parallelogram has congruent sides that are opposite each other, right? So the opposite sides of a parallelogram are congruent. So I know this one and this one are congruent, and I know, say, JE and AC are congruent. So if I can prove that these 2 are congruent, then all 4 have to be the same length. So that's what I'm going to do. I'm just going to go ahead and use the distance formula, or the Pythagorean theorem in this case, to figure out if these 2 side lengths, JE and CE, are congruent. So are JE and CE congruent? So what do we need to do? We need to look at our distance formula. I'm going to use this version of the distance formula because I prefer just thinking about the change in x, which is, say, this distance, and the change in y, this distance. So if I'm going to figure out the length of JE, that's all I really need is just this length here and this length here, and let's go ahead and do that. So JE is going to be the square root of 3 squared plus 4 squared, which in this case would be 9 plus 16, or 25. So the square root of 25 is 5. So that's the length of line segment JE. And remember, you don't need to put the bar on top if we're talking about line segments. The length. So let's figure out the length of EC, and we're just going to do the same calculation. So 3 squared plus 4 squared is 9 plus 16, which is 25. The square root of 25 is 5. So yes, these lengths are the same. So we can conclude, therefore, parallelogram JACE is a rhombus because consecutive sides are congruent. We do not need to prove all 4 sides are congruent because we've already been told that it is a parallelogram. So if it's a parallelogram, we know the opposite sides are congruent. And so if we know these consecutive sides are congruent, all 4 must be congruent. So we've proven that it is a rhombus. The other thing you could have done instead is used this fact here that diagonals intersect to form perpendicular lines, but that's going to be a different calculation. That we would have to use slope. So we could prove that these diagonals here are perpendicular, but that's a different calculation. So I hope this helps with the distance formula and gives us kind of an introduction to how we do these coordinate proofs. And please let me know if you have any questions.